Hello interwebs, welcome to Let's Fix Computers. We're still on gadgets again today. It's just been a spree of gadget videos, which I'm not doing deliberately, it's just what I've got in that seems interesting to me at the moment. So I've got a big, huge Dymo Label Printer here. This came in from a local electrician who unfortunately said his colleagues through various use had mullered the USB port on it. As you can see, there's a USB mini port there that's just completely mangled. So the main objective is to get to that port and replace it. However, we're gonna take a look at this thing and tear it down and have a look at it while we're at it, because that's interesting. So firstly, because I can, let's just turn it on so you guys can see what this thing does. Label printers are, it's a pretty indispensable tool for anyone who does any kind of site work. I've got one myself. That's my cheapo brother label printer, and they're pretty simple. You turn them on, you type in a message such as cabinet number whatever, you hit print and it will spit out a sticky label that you can attach to stuff. Really good for labeling up your patch panels and that kind of thing, and then you've just got a little trimmer there that just trims off the label. So these ones are relatively inexpensive, but the big ones like these can be really expensive. I wouldn't want to put a price tag on it, but I know that it'll make your eyes water considering what it's supposed to do. But this one, as you can see when I turn it on, it's actually got a full graphic display on it and everything, which is one of the reasons why they seem to be expensive. Although honestly, I'm not quite sure what the major benefit of this one is, but you can do graphics and stuff like that with this. As you can see from the label output, it prints really wide stuff, so you can probably do like sort of, almost symbols and pictograms and things like that. So label cartridge missing. Yeah, so this thing has a touch screen on it, and yeah, so as you can see, it actually has a small an interface, and you can make up a custom label in custom fonts and so on and so forth, and then print it out on the go. So that's what this thing does. Now presumably that USB port is so you can import stuff to it. So you can connect it up to a computer and you can do all your label design on the computer, and then this will print off of the computer. So I'm guessing that's what's going on here. Right, let's turn that thing off and let's take it apart. Quite a long persistence of vision on the LCD after that turned off then. That was kind of interesting. Right, okay, so if we turn this thing around to the back, we've got a whole bunch of T10 screws, and we've got that's probably going to be the battery compartment there. Yep, battery compartment with a 2000 milliamp hour 15 volt battery. So yeah, fairly beefy LiPo battery there. And then under, well, we'll leave that off. Then under here we've got, that's where your tape cartridge goes. And these label printers usually take a sort of standardized cartridge that's quite easy to change out. So you just plonk that in there, and as you can see, it's got two real feed pickups. And there's some contacts on either side for detecting the cartridge type. And then there we've got a hotbar printer. So that's a long strip, and by heating it up at various points as the label feeds through it, you can then, using thermals, just print an image onto the paper. Same way that most like tills, shop tills work and things like that. And then we've got what looks like a electric mechanical cutter on the end there. So that's kind of cool. Right, I'm going to disconnect the battery while I work on this thing. Let's take that guy out. It looks like you could fit a slightly bigger battery in there if you wanted to. Right, okay, let's take out all of these Torx head screws so we can get into this thing. Right, that's done the job. Is that lift? Ooh, yeah, things are lifting off. Okay, right, hold on. What's coming apart and where? I'm just going to split that slightly because we've got all the electronics are staying on the front, but the printer's staying on the back. Okay, right, let's start unplugging these wires. Oops. Okay, that's fine, that's fine. Lots of ribbons connecting the front to the back here. I'm not really comfortable with that. Where's my tweezers? Okay, and right, the last one is a grounding strip by the looks of things. Okay, I'm gonna undo that. Okay, so let's have a quick look at the printer module. So this is more or less all one complete unit here. It looks like most of we've got a big, huge gearbox at the back here that is looks like it's a bit of dual function. It's all of the paper feed and stuff like that, and then there's some kind of sort of spring mechanism there as well. Don't know what that's all about. Maybe to do with the cutter or something, I don't know. So I've just noticed there's some more contacts up the back there which seem to align. Okay, so those contacts then go back to that bit there, which goes into here. So that's probably part of the detects what type of tape you've got loaded in there. And then this cable here also has more contacts going to the left and possibly all the way over to the right. So again, this is all contacts for detecting the type of tape that's loaded in the device. Then this bit here, that's the trimmer, the cutter. So that cuts off and does other things as well. I would wager that this is just for the trimmer and the feed roller. Although that might be this guy here. This goes directly into what is clearly a motor drive there. So that's feed control. Then that is a trimmer and something else, not sure what. And then finally we've got 3 ribbons which seem to manage the actual thermal printing. So yeah, and they've got some fairly beefy traces on them as well. That's just a 4 trace thing, but you'll notice on these ones that we've got some thin traces in the middle, but the outer traces that go to, what's that, 3 pins on the inside and outside are really wide. So those are obviously power lines. So they're carrying the big current handling stuff, which again, because it's a thermal printer, there's going to be quite a bit of power going down those to actually heat up the thermal elements in there. So that's what that is all about. Cool. Right, then on the front panel, we've got all the digital stuff. So that's where the battery connected, and we've also got a little push button switch there, which is probably a reset button. There's our broken USB port. So that's through hole mounted directly on the board. So we've got to take this board out to replace that connector. Then we've got this grounding strap just to make sure that the well, I assume that's ground anyway. It must be. I can't think of anything else that would just be attached just with a ring connector like that. So that must be a grounding strap to keep the printer grounded to the main logic board. Those are our 3 ribbon connectors. We've got the display connector coming through here. Then there's that is probably our keypad there on that connector. And that's about all we are interested in. The rest of it is all just going to be digital logic. You can see we've got rows of resistors and a bunch of capacitors about here. On the other side of the board here, I would wager we'll find the main controller unit. You know what, let's take this out because we need to get to that USB port anyway. So let's disconnect these ribbons. Whew, seriously tough screws on this thing. Right, so will that lift out? It will. Yeah, there we go. So our LCD's behind there. That lift out? It probably does. Oh, that looks like that's a sliding malarkey. I'm not going to take that out though. There's no benefit to that. And then keypad there. But this is sort of set. Looks like it's sort of splash proof. So I'm going to leave that all alone because it could be sealed. Right, and then if we turn over this board we've just removed. So we've got about 4 major chips on this thing. We've got this fella here, which is who made it again? So this was an NXP ARM microcontroller. So it's an ARM processor, so it runs mobile stuff. And this thing has, it's got a built-in keyboard, LCD, touchscreen, and Ethernet controller on it. So this thing is probably the main processor for the interface, because that can directly drive the LCD, the keypad, and it can also handle the I/O for the device, the inputs and outputs. And then that's probably got a RAM chip and a ROM chip. Not sure which way round these things are, but one's probably RAM and one's ROM. And then we've got this fella here, which is also a Cortex M3 CPU. And this one, my guess, is controlling the printer. So we basically have a computer and a printer on the same board. Right, so let's start looking at the bit we're interested in, which is that USB controller. And as we saw from the top side, it is a through-hole device. So we've got pins sticking all the way through the board, which might make it a bit of a pain in the ass to remove. I'm going to try and hot air that off the board, because in my recent experience, just hot airing connectors off the board is the way forward. So let me see. I'm not going to try and clamp that up. I'm going to place that on my heat-proof mat, which is the top of the hard drive. And we're just going to start belting that with hot air and try and not melt this wire in the process. This is a big connector. I'm not sure if this is going to work. I can just mercilessly melt the plastic though. Right, I'm going to soldering iron out the last of those bits and pieces, because we've removed the main bulk of the connector. However, all of the pins fell out, and we've also still got the anchor points in there and stuff like that. So we'll do a little bit of tidying up on this and clear those holes, and then we can track down a new connector. And that's going to be fun, because the old one is mangled to heck. But I think that is a standard through-hole USB mini connector, so I don't think we'll be hard-pressed to find one of those. Right, I couldn't get the data pin holes clear, despite my best wicking efforts, but as you can see I've got the anchor holes clear, so that's ready for a new connector now. We can hot air a new connector on from the back, and I think that'll be fine, and it'll drop straight in, and yeah, should be right. Let's get a new connector. Right, here's our new USB micro port. As you can see, it's all a through-hole one, so it should be fairly tough, as long as it doesn't get mangled again. So for this, I'm going to heat up the back of the board to melt the solder that's still in the holes, while I use some tweezers just to press this guy into place. And once it's through, I'll finish it all off with the soldering iron. Everyone on YouTube uses Q-tips to clean up. I find the toothbrush is much more effective. If your toothbrush is taking components off the board, then either your circuit board is really fragile or you're being way too vicious. There we go, look at that. Like I bought one. And what I'm going to do, I'm going to put a little bit of extra solder just on this side, on those anchor points there, just to give it a little bit of extra, beef. There we go. I'm quite chuffed with that finish. There's the bottom. There's the top. So as you can see, I've just blobbed a little bit on those anchor points just to add a little bit of extra bonus strength there. Probably won't do a lot, but you know, it helps. Right, Now, it took a couple of days to get that USB connector in because it looks like I picked poorly on my eBay listing, and it's been a week since I took this thing apart now. So let's hope I can remember how to put it back together again. So let me see, we've got to put the board onto the front panel, I remember. So we need this guy, and that's going to go into here somehow. Right, the port is going to go up there, so it's going to need to go that way round. Alright, this is going to be tricky getting all of this hooked up at the same time. I'm going to put them side by side like this. This is angering me already. Can I just... This cable is just folded in such a weird way that it doesn't want to sit anywhere. And it's really hard to get my hand at just the right angle to reconnect it. Oh! There we go. That's one. Now I've got to figure out which way round these two ribbons go. I've got a horrible feeling that these are both the same width. Oh no. Nope, that one's wider, I think. Yeah, there we go. That one was like 1 pin wider, so we're okay. And then we've got this guy here. And then finally, that guy there. And I can just see the top ribbon has jumped out. And by extremely good fortune, I just happen to have just picked it up at such an angle that it's easy to reconnect again. That was very lucky. Okay. Now I'm going to reconnect the battery and just see if it turns on. Unfortunately, I don't think I have any label cartridges for it. I've got a case that it was delivered to me in, so I'll have a root around in there and see if there's anything in there. Right, maybe the battery's flat. Let's plug in its charger. Something's not right. It doesn't seem to be turning on. Oh, there we go. Label cartridge missing. Cool. Good, okay, right, we're safe. Good, it was just a flat battery. Cool, okay, let's turn that off again. Right. I'm going to put in 2 screws just to stop it from falling apart. Let's load the cartridge in there. Sure they won't mind me breaking this one open. So by the looks of things, it can take different widths of tape, because that's hot. So that's 12 mil across and 7 meters long. And depending on which tape is loaded, depends on which contacts are in place, it would seem. Cool. Okay. Current label is not compatible with the new label cartridge selection. The label will be closed. Save it, I guess. Okay, let's do a quick label. Adamant IT. Okay. Print. Maybe. Is that print? Printing. Yeah, boy! There we go. One label. So where it's a new one, obviously, you know, it needs to feed a little bit, but then it'll be better quality. But there we go. One label. Done and done. Okay, right, that's it. We're all finished. Thank you very much for watching, everyone. I'll see you all next time. Goodbye for now.